In our previous lecture, we have seen the assumptions of quantum free electron theory and success and drawbacks. And we have also seen the Schrodinger wave equation is representing the motion of the electron in the material. So in this lecture, we are going to see the how the electrons are distributed in various energy levels as per the quantum free electron theory. So this concept was explained based upon the Schrodinger wave equation. So here in this concept we are going to see the distribution of electrons. Distribution of electrons in energy levels as per quantum free electron theory. Okay, so as we see that as per the according to the Schrodinger wave equation, del square psi plus 2m by h cross square into E minus V into psi is equal to 0. Now according to the quantum free electron theory, electron is moving in a uniform potential field. That means there is no potential energy acting on that one, so we can be considered as a 0. Now del square psi plus we will get 2m by h cut square into psi is equal to 0. Okay, to solve this equation del square psi plus we can assume this value with a constant k square, psi is equal to 0. So k square is equal to 2me by h cut square and k is equal to, from this one we can write the value energy E is equal to h cross square k square by 2m. Let it be 1. Okay, and we can also write the kinetic energy of the electron is equal to half m v square, that can also be written as m square v square by 2m, that is p square by 2m. Now if we can compare equation 1 and 2, we will get the momentum of the electron p square is equal to h cross square k square. So that implies p is equal to h cross k. So this is the momentum of the electron inside the material. As we know that h cross c can be written as h by 2 pi. K is the main wave vector of the electron, because as the electron moving inside the material, it moves as a wave, material matter wave, and it is having the wavelength. So the wave vector of this electron is k is equal to 2 pi by lambda. Now this second order differential equation, let us assume that if the electron is moving in x direction, this equation can be written as dou square psi by dou x square plus k square psi is equal to 0. Now you can write the solution of this equation, psi is equal to some a sine kx. If you can substitute it and solve this equation, you will get the k value as n pi by a. Okay, so therefore the energy of the electron can also be written as h cross square into n square pi square by a square by 2m, and we can also write h as h square by 4 pi square into n square pi square by a square by 2m. So this equation becomes n square h square by 8m a square. So this is the energy of the electron when it is moving inside the material. So according to this equation, if we can see for n is equal to 1 level, okay, what will be the energy? E is equal to h square by 8m a square. Now what will be the next energy level? N is equal to, for 2, the value becomes almost, the energy becomes 4 times h square by 8m square. For n is equal to 3, If you can take it, then what happens is the value becomes 9 times greater. So if you can observe all these energy values, these values are not continuous. Okay, so according to the quantum free electron theory, the electrons are staying in discrete energy levels. They doesn't have the continuous energy levels. So see here, after this h square 8m square energy, again 4 times more energy level will exist where the electrons can stay. So according to the quantum electron theory, free electron theory, what is the conclusion will be the electrons are having discrete energy levels. The electrons are having discrete energy levels. And the energy of the electron is n square h square by 8m square. And what are the final conclusions? Momentum can be written as h cut k. Energy can be written as n square h square by 8m square. And energy can also be written as h cross square k square by 2m. In the next session, we will see the Fermi energy level.